Hello everyone, this is another episode of Fun.net, and today we have two guests. We have Olivier and Tamás. Hi guys.
Hello.
And you work on a product that's called SonarLint, right?
Yeah, that's kind of right. We work on multiple products, but we can discuss it later. We have a couple of products which cover like a whole range, the whole range of development. So basically starting from development box code analysis tools and team solutions as well.
Okay, so you work on more than that. That's what I got wrong.
Yeah.
Yeah, SonarLint is one of the products for the IDE, and we have some others. There is mainly one other which is called SonarQube, which is more for teams. And all those products, they are targeting code quality management, basically. We call it continuous code quality.
And do I understand it correctly that those products are built largely on Roslyn?
Yeah, so one part is fully based on Roslyn. So SonarLint is a Visual Studio extension, and that's fully on top of Roslyn. And SonarQube is actually using the analyzers which are in SonarLint. So that part is based on Roslyn. But it's like a whole web application, which is of course not using Roslyn. It's a web application.
Okay, so code quality is your focus.
100%, definitely.
Okay.
And within code quality, we actually cover 3 domains. There are 3 subdomains. One is maintainability. So basically, what you have built so far, how difficult is it going to be to be changed, maintained tomorrow? One is about reliability. So what you are going to deploy to production tomorrow, how likely is it to crash? And the last part is security, which we are starting on, which I probably do not need to explain what it is. I think it's obvious enough.
Sure. Okay. So do you wanna switch to a demo right away, or do you want to talk about it a little more, or how does that sound?
Yeah, I think we should switch to a demo on. I think we'll start with really what you should start with. When you talk about quality, the best way of not having to deal with quality issues is not to introduce them. So we should definitely start with the development part, which is really IDE. Tamás is going to show us how you can avoid to introduce problems.
All right, sounds great.
Yeah, so
can you
let's get started.
Your font size maybe a little bit?
Yeah, definitely. 150 it is. Okay. So I'm going to demo SonarLint. This is, as you can see, I'm going to stay inside Visual Studio actually. So this is a Visual Studio extension, so you can get it in extensions and updates. It's on the marketplace, so you can search for SonarLint and you just simply grab it. It's there, it's free, take it, use it. It's for 2015, this version, because as you can see, I'm on VS 2015, but we've got the same running for VS 2017. So I've got it installed, so I'm not going to install it. So as Olivier said, we are actually trying to find maintainability issues, bugs, and security issues. So let's get started. And as I kind of thought it would be a good way if I don't just demo on a small project, but show issues on real projects like Roslyn itself. Roslyn, everyone knows what Roslyn is, but in this case, what's interesting in Roslyn is that it's a very large code base, and also it's pretty new, so the quality should be relatively good. I think it should be very good, and generally it's very good. But as you will see, we can still find issues in it. So let's get started. And so I'm going to show a couple of green squiggly lines here. Let's start with this one. We have identical sub-expressions on both sides of operator and, which is rather strange. It's usually a copy-paste bug. And if we check out parameters, we see that, okay, we've got two very similar parameters here. So one of them should have probably been used. So actually what I'm going to show you, these are kind of bugs, whatever bug I show you, we already submitted a pull request for that in the Roslyn repo, and these were already accepted. I checked out an earlier version because, as you can see, I'm on VS 2015, and Roslyn right now doesn't build on VS 2015 because it already uses C#7 features.
Right, but that's a good catch.
It is. Yeah. Pretty nice, isn't it?
Yeah.
So this is, we can talk about implementation details as well if you'd like, but this is something which is very easy to implement in Roslyn, and I'm always surprised how many bugs we find with this one.
Yeah, actually, I would be very interested to see some implementation here.
Oh, okay. So you want to see implementation as well? Okay. So how about if I show a couple of rules and then we jump to the implementation, and then we come back for more issues, let's say. Okay. So let's go on to another one. This is not a bug. It's more like a maintainability issue. This variable is never used. This parameter is not used, so I have it. It was probably up there because of refactoring, but you can get rid of it. And there are a couple similar issues in this file. So there are unused private members, so why have it? Remove them. These are, again, something which are very easy to implement. These are fully based on Roslyn. So as you can imagine, this part only uses the syntax tree, while if we are talking about unused members, then we need the symbol resolution. So we are using the semantic model here. So let's go a bit further. Again, this is something which is using the semantic model. So web client is an iDisposable. So ideally, it should be disposed, but as you can see, it's a local variable and it is not disposed anywhere. So why not do it properly? So we are basically looking for iDisposable implementations and see all its references. And if dispose is not called, then we raise an issue.
Yeah, that's very useful. Does it suggest fixes as well?
For some rules, it does. For some other rules, it's very difficult to suggest code fixes. For this particular one, we don't have code fix. For the previous one, which was, let's say, this one, for this one, we do have a code fix, which will remove the parameter. And in this case, this is very important that we don't really want to report false positives. So there are iDisposables which should be disposed, but actually no one cares about disposing them, like memory stream. On those, we don't report. So we've got a blacklist on which we report, and we try not to raise false positives.
Makes sense.
Yeah,
because
so
a big problem with analyzers, and it's not specific to this product, is that when you run them for the first time on an existing project, you get kind of overwhelmed by the number of issues.
Exactly, and Olivier will. I'm pretty sure Olivier will say a few things about like baselining in the team solution which SonarSource is providing.
Yeah, so it's really the base of the approach we recommend to code quality, which is really to forget about the past and really look at not introducing new problems, which already makes a huge difference. Mm-hmm. So it's a fully baseline.
Yeah, so it's not making it worse rather than trying to fix everything.
It's even better than this. When we say not making it worse, very often we mean, okay, if there were 10 issues before, do not live with more than 10. We go a little bit further than this, which is to say, because if you say that and someone fixes one, it kind of gives a permit for someone else to fix one.
It shouldn't be like carbon credits or something like that.
So what we tend to say is we say, okay, from now on you do not introduce new issues. So if someone fixes an issue, the overall number is gonna decrease, basically.
Makes sense.
Yeah, so we'll see this in detail in the SonarQube part. I would say that makes sense there. So here's another one. This anon is marked with flags, but the members are not initialized, which is either good or not. But in this case, this is 0, this is 1, this is 2, this is 3. So I'm not even sure if this was meant to be written like this, but this basically will mean from source module. And I'm not even sure if this is correct or not. So maybe someone could pick it up in the Roslyn team.
So how do I make this one go away?
How do you make this one go away? If you initialize all members, so you initialize this to 0, you initialize this to 1, and so on. In this case, we are not sure if this should be 3 or 4. Let's say it's 3. That's also perfectly valid for flags, anon. And then after a while, if everything goes well, the issue goes away, and you are done. Or another approach is to remove the flags.
That's one of the big advantage to have based our analyzer on Roslyn, which is that we benefit from all built-in features of Visual Studio, which is we get immediate syntax highlighting, we get new issues directly in the list of issues, etc., etc. Mm-hmm. So it's a pretty good integration with VS.
Is there also something to ignore an issue?
Yeah, you can always go through the standard Roslyn tooling. So you can suppress an issue in source code, or you can suppress in a file as an assembly level suppress message attribute. So that's standard Roslyn tooling. So we didn't have to write anything about it. Mm-hmm. So let's see one more, and then we can check implementation, or let's check a few more. So here we get something saying use a null check instead. So what we have here is we've got an interfaces, which is an immutable array of name type symbols. So the first element of it is going to be a name type symbol. So basically, what does the is do here? It basically checks if that's not null. So we have these simpler ones, which are all Roslyn based. It uses diagnostic analyzers.
In this case, you're not changing behavior, but you're expressing the real intent, right?
Yeah, exactly. Which is a maintainability issue, but a future maintainer will help you, actually. So let's see what we have here. Oh, okay, so remove this call from the constructor to the overridable make parameters method. So make parameters is actually virtual, so you can override it in a base class, and calling virtual methods in a constructor is not a good idea. Why? If you don't know why, you just simply click on the ID here, and that will drop you to a nice detailed page with explanation, non-compliant code sample. Also, you can check out other ones. somewhere we have compliance solutions. So this is all linked together. It's versioned, so whenever we release a new version, the documentation gets a new version. You can filter for bugs, you can check out the issues. Actually, if I go to the home page, it says that we've got 185 C# rules. And as you can see, we also have a couple for VB.NET.
Nice.
So, and then here's another issue. This is a lot more complex to find this issue than the previous ones. So we say that pointer is null on at least one execution pass. What that means is that if pointer is null, this call will always throw a null reference exception. So let's see how this happened. We've got a pointer. If pointer is not null, we do something and then we return. So whenever we get here, pointer is gonna be null. So again, this is a copy-paste issue. Reference was checked here. It should be reference actually. This is also fixed already in the Roslyn repo. The pull request was merged. So, but this is, as you can imagine, this is a lot tougher to find this issue because for this one we need control flow graphs, how the control is actually flowing through this this method, and then we need data flow analysis as well. So what we did in the last year, or a bit more than a year now, is that on top of Roslyn, we built our own CFG and data flow analysis engine. So we can find issues like this. And I think this is a good point to go to the source code right now and check out how we implement things. So I'm going to just open up SonarLint and what are we looking for? We should find, let's say we should go for a simple rule like the binary operator should not have the same operand on both sides. So we will find this somewhere in rules, and binary operator with identical expressions. So again, I zoom a bit just so that you see. As you've seen on the website, we've got a couple of filters. So we have our own metadata attached to rules so that we can easily generate the website. We've got descriptions. Okay, so this is almost standard Roslyn code. We've got our own Sonar Diagnostic Analyzer base class, which does a bit more than a diagnostic analyzer, but this one derives from diagnostic analyzer, as you can see. So, and this one comes from Roslyn itself. And then what we have here is that we define which operators we care about. Why not all binary operators? Because we probably don't want to report on addition, because that's too common to actually do. Like add 2 + 2 is not a bug. So we will subscribe to a couple of syntax kinds, and then okay, yeah. So this is assignment. So we even handle plus equals, and then okay, let's go into this one. We have a binary expression. We take the left, we take the right, we take the operator token, and then we do something with them. What do? We check if they are equal, removing parentheses, and if so, then we report an issue. That's basically it. It's that simple. So, and then code fixes are, of course, can be added if you know how to do. For this one, it would be very difficult to add the code fix. So coming back to the more sophisticated implementation parts, which are the control flow and the data flow analysis, I've got a very basic helper application here. So I just copy pasted here the code fragment, which we've seen before. I'm going to simplify it a bit just to not have that much noise on the screen. And I'm going to explain what happens when we actually process this. So I'm going to hit F5 on it, and this will show me a control flow graph of this code piece. And stop me if you don't understand, stop me if it is too detailed. It is very technical, actually. So what is a control flow graph? Basically, a control flow graph is your expressions and statements, how they follow each other. Mm-hmm. So in this image, what we see is that we've got all the expressions. So type reference is an expression. Type reference as I pointer, type reference is also an expression. And all the arrows are basically control flow jumps. So, and you don't see the statements because statements basically just help you navigate between the blocks. So this is our first block. What we have here is that, okay, the evaluation order of this code piece, which we have here, starts with this line. How do we evaluate it? We take this one. That's an expression. That's an identifier name syntax. So that's an expression. If you check IL code, this will get evaluated. This could be any expression here. Then this is an expression as well. This gets evaluated. Then whatever is here is assigned to pointer. And we see all of these happen here in our control flow graph implementation. So first expression, second expression, the third one. Then, okay, we actually got to a semicolon. So this is a declaration, but it could be an expression statement. So in that case, okay, we start new. What's the next thing which gets evaluated? It's going to be pointer. What's the next thing which is evaluated? It's null. What's the next thing which is evaluated? If pointer is not equal to null. So we will see that here. Pointer, null, pointer not equal null. And then when we evaluated this one, here comes a branching. Basically, we either come here or we come here. Mm-hmm. So we either come here, append assembly qualifier if necessary, or we come here to this statement, but this statement is evaluated as this one, so it starts with type reference. So that's why we see that here. And so on and so on. You have to do this for all expressions and all expression types and all statement types in C#. So you will handle even the undocumented keywords like underscore, arglist, and you will handle all the collection initializers, for example, like, and you need to make sure that whatever gets into the control flow graph is actually the good evaluation order, because otherwise it won't work. So that's one part. We've got the control flow graph, and then we need data flow analysis. What we do is we keep track of assignments, like what gets assigned to which variable, and we keep track of comparisons. So, and null assignments also, like we want to see things like where a variable is null, where a variable is definitely not null, where a condition is always true, where a condition is always false, where do you access a nullable value, where you know that the nullable itself is null, and things like that. SonarSource has many analyzers for different languages. So I think SonarSource supports like 20 something languages. So this is only for C#, what I'm showing, but data flow analysis has been implemented for JavaScript, for Java, for C, C++, and I think that's it. Olivier will correct me if not.
Maybe COBOL.
COBOL.
Great. I'm sure lots of people will be ecstatic about that.
You would be surprised. You would be surprised.
I'm sure I would be. That's not the issue. Is it fair to say that this type of data flow analysis is even more useful in dynamic languages such as JavaScript that you mentioned?
Yeah, exactly. In the end, if we have time, I will show a minor demo on JavaScript because as you can imagine, in C#, it's pretty easy. We can always know the type of a variable, or almost always we know the type. But in JavaScript, that changes. So what the JavaScript team implemented at SonarSource is that, okay, even the type of a variable is tracked through the control flow.
Yeah, exactly. I was going to say, in C#, this is super useful for null refs. In JavaScript, it's even important just for basic type checking.
Yeah, exactly. So, I mean, when we have time in the end, I'll definitely show that. So, I'm not going to jump into the implementation of the control flow graph and the data flow analysis, because as you can imagine, that's rather complex. But you can have a look. It's open source. It's all on GitHub. So definitely, if you find anything in it, just report it.
We'll give the pointers to the repo.
Yeah. So let's get back to Roslyn source code, and just check out a couple of similar issues, what we have here. So this is pretty good. I like this issue. We report here that NewType is null on at least one execution pass. But if you check the code, you see that type not equal null and NewType not equal null, and something comes. So it kind of seems wrong to report here, but it's not. So let's check out what's here. It's something and something else, or a third thing. So if you know the precedence of and or, you will see that, okay, if this is false, we can still get here. And why not report on this occurrence of NewType? Is because is NumType an extension method, and extension methods could be called on null. So as I said, we don't want to report false positives. Maybe the content of the body of is NumType would handle the null case. But this is a property access, so this will definitely throw if we get here with a null and NewType. Okay, here's another one. This is fairly simple. So semicolon token is a syntax token. Syntax token is, okay, let's navigate there, is a struct, and you know a value type is never null, so that comparison is always going to return false. And I can get back to this when a value type null or not. We all know that it's never null, but as I said, we are tracking null assignments, and actually you can assign null to some structs like nullable of t. That's a struct, and you can still assign null to it, although the compiler will change it to a constructor call, but syntactically you can still assign null to it. Also, pointers, if you, anyway, I won't get into this one. So what do we have here? Receiver type is null on at least one execution path. So let's see where that is being assigned. It is used here, here, and here. But here, we check if it is null. So it can be null. And then, okay, we skip that if, whatever. There's no assignment in the if. So we can actually get here and receiver is null. I think I've got like 3 more. So this condition is always false. Why? Because we already checked it here, and then we return. So whenever we get here, they are different. And so this condition is always false. And although we share the basic concepts in the different language implementations, so for Java and C#, there are similar concepts in the data flow analysis, but there are some differences. So, for example, if this operator is an overloaded equal, then the C# data flow analysis will consider that as a value equals and not a reference equals. And reference equals implies value equals doesn't imply reference equals. So these things are also taken into account. Okay, what do we have here? Yeah, computers are pretty good at doing bool algebra. So when we say that this condition is always true, I kind of believe the analyzer, but we can actually check it out. So when do we evaluate this thing here? We only evaluate this if this is true. So if this is true and this is false, then we return. So when we get here, this is always true.
Wow.
In this case, I wouldn't fix it because this structure of the code shows a pattern. So I probably wouldn't fix this issue, but it's good to know that it's always true and it's a redundant thing there. And one final thing, which is kind of specific to C#, and we talked about it. So underscore succeeded is a nullable bool. We check if it is equal to null, do something, and then call a value on it. What will happen in this case? If succeeds was null, then we actually don't get the null reference exception. We get an invalid operation exception. How do we fix it? For example, we can check if it has value, and actually we do check if the code has value. So we learn on has value, and then we don't report on it because we know that, okay, now we know it has a value, so we can call value. So I said that this is .NET or C# specific, but actually in Java 8 there's the optional, I think it's called optional class, which has very similar methods like has value or is filled, or I don't really know the name. So these are kind of the things which we can spot, and this shows that even in Roslyn, which is a pretty good quality code base, we find issues which definitely needs to be fixed. So this demo was a bit longer than expected, so I'm gonna stop demoing now and let Olivier show the platform or what he'd like to show.
Excellent, thanks.
Yeah. So I think it was pretty good to see how it works for a developer in the IDE. We actually at SonarSource we didn't start by developing SonarLint. We started by developing SonarQube because we thought that really code quality should kind of be shared among the team. It should be like a shared ownership among the team. So you have a project, everybody should be responsible for code quality. So here we have a product which is actually our most famous product. I think it's called SonarQube. It used to be called Sonar. You have two ways of using it. One is you download it on sonarcube.org. The other one is you go to sonarcube.com and you can use it online. We have an online version in the cloud. And really, this product is for teams on organizations. So here we saw you are developing. You kind of have we saw existing issues, but if you type new issues, it's going to act as a spell checker. And then it's important that as a team you also share best practices, policies, and you also have the ability to see all the products. So this is where SonarQube comes into play. So what I'm showing you now is actually our own instance of SonarQube, the one we use at SonarSource. So we eat our own dog food, or we drink our own champagne, as some others say.
I prefer that. We should do.
Yeah, I know it's a little bit elegant. And so you can see here we have 74 projects at SonarSource. So here, if you search for this, you would find our Sonar C# analyzer. You would find our Java analyzer, COBOL, etc., etc. As Tamás mentioned, we support today, I think it's 19 different languages, with 5 which are like mainstream: Java, C#, C, C++, COBOL, and JavaScript. These are our.
You are really not kidding about COBOL.
We are really not kidding about COBOL, and I don't mention RPG, PL1, or ABAP either. That are kind of old languages which we support. But you know,
there is
200.
There is money to be made, right?
Yeah, 200 billion lines of COBOL in production nowadays. You have to do something about it. You can't ignore it.
No.
So obviously, one of the big feature of the product is it's multi-language. So you want to analyze many different projects in many different languages. You can do that. If you have a language which is made of, you know, C#, JavaScript, some HTML, you also can analyze all of that at once, and you get issues which are reported specific to the various languages. Here, when you go to SonarQube, you can see all the project with some indicators that I'm going to explain in a few minutes. It kind of acts as a big radiator. So here you can find out about projects which have difficulties in reliability. You know, here we have a C, security maintainability. We look at code coverage by unit test. We look at we have clone detection. So we look at duplication. So basically all aspects of code quality. I'm going to show quickly a couple of services which are very useful for teams. So if I go to what we call Qualityget, here you can find it's a service which actually enables you to define what quality means for your team or your organization. What we recommend, and that's actually the default, it's not the default at SonarSource, but it's a default in the product. We actually recommend to start with very basic policy, very basic Qualityget. Code coverage on new code should be greater than 80%. It can be 17, it can be 50. Doesn't really matter how much number you pick here, but what's important is that you decide that whatever code you add, it's going to be covered by unit test. You don't looking at coverage after the fact. You know, like you have an application which has 15, 20% of coverage, and you try to make it 50. Not very good. It's pretty useless in general because you write kind of a monkey tests to try to get to get to the number. You are not testing the changing code. You are testing some code which may be very static. So it's not as good. We actually push a methodology at SonarSource which is called water leak. So where we say that you should manage code quality the same way you manage water leak, which is the very first thing you want to do is fix the leak. Before you even start to deal with what is already on the floor, just fix the leak. So here we apply the same thing. You can see the entire Qualityget is based out of this metaphor: coverage on new code, maintainability rating on new code, reliability rating on new code, and security rating on new code. We recommend to only look at that. And if you think about it, the more you are going to make changes to your applications, the faster the overall application code quality is going to increase, because every time you will change code, it's going to increase. I don't know if you know, but I think it is it's an industry number. Companies, they change in average between 15 and 20% of their code base every year. So it means that if you apply such a strategy, you actually are going to increase the code quality very rapidly. Year one, it will be like, let's say 20%. Year two, it may be like 30, 35%. because there is overlap between your one and your two. Obviously, after 5 years, you may have remediated like 40–50% of your code base, which really is quite a lot. So Qualityget for this is very useful. You define the policy here, and then you can apply it anywhere. So I mentioned earlier that we try to be present at all stages of development. When you go to production, when you are about to release, you can basically test the quality of the code which is going to production versus this Qualityget and make sure you are meeting the criteria. So it is pretty powerful. So we define it here. Of course, we define also the rule set you are going to apply. So you can see it's done by language. So the SonarWay has 127 rules that you can browse here. So when you have the ability to browse all the rules by quality profile, by type, bug, vulnerabilities.
And just to mention, so the difference between
by language.
So the difference between the numbers which you saw on SonarLint website and here is that these are the enabled rules, by default enabled rules. There are certain rules which we think they are not generally applicable. Those are disabled by default, but you can turn them on. And there are more rules than this 120 something.
Yeah, that's right. So here you can also configure the rules. Certain rules, they take parameters, depends on the threshold, for example, you want to use. So this is where you do that. On once you apply this rule set on your project, of course, you are going to get issues. And here you can see we have many issues. So here you have all the tooling to be able to filter out, to basically investigate if you want to know, about here blocker issues. If you want to know if you have specific rules, security rules you want to apply, like OWASP or MISRA, error handling, you have the ability to filter out, and then once you see the rule, again, as Tamás mentioned earlier, you can see a little documentation, and it was not a good example here, sorry about that. In any case, you have the ability to see the rule in context, so you can go from the issue. Okay, that was a very bad example, sorry. Empty file. So you have the ability to basically see the code at the end, which I couldn't find an example for, but anyway. So
what if I want to implement some custom rules? For example, I want to check that all of the namespaces that people come up with are the name of my company or whatever.
So here, obviously, it's going to depend on the language. If you want to implement a C# rule, you would need to write a Roslyn rule, basically. You would base it on Roslyn. If you want to implement a Java rule, you would write a Java class. You have this ability. All of our, not all, but most of our analyzers, they are extensible, for sure. The one thing I would tell you, if you were to tell me, I would like to write a custom rule, I would tell you what's the spec of this rule, because if you provide us a spec, we would probably be very happy to do it. If it applies to many people, we are very happy to enhance the product. If it's something very specific to your environment, in that case, you have the tooling to write your own rule.
And talking specifically about .NET, so basically you would write your Roslyn NuGet package of your rule, and then from that NuGet package, we've got a tool which generates a SonarQube plugin. And you can install that plugin into SonarQube, and there you go.
Okay, sounds good.
Yeah. So if we go back to what Tamás showed earlier, Tamás was in a specific project. Here we are basically navigating throughout every single issue in the Sonar source ecosystem. So out of all of our 74 projects, we have all these issues which are currently open. Now, I also would like to show you another part of SonarQube, which is more the dashboard part for each project. You get a dashboard here. So now I'm showing you SonarQube on SonarQube. Again, we are drinking our own champagne here, it's a very recent analysis. It was actually analyzed yesterday, so March 29, and you can see that we are currently not passing the Qualityget. So if we wanted to release just now, we couldn't. We have a couple of issues to fix. So here, what we try to do really is to give you three information very, very quickly. One is, do you pass-fail Qualityget? So it should be immediate action if you fail. The second part is the left part here, where you actually see the state of the project. So currently we have 4 bugs open, 0 vulnerability, about 2,000 what we call code smells, which are maintainability issues. So here you find things like style, anything which doesn't help to maintain, like complexity, duplication, all of that would go there. We also show coverage and duplication. And just would like to show you something about coverage. I mentioned earlier this leak approach that we have to quality, and I think coverage at Sonar Source is the best example of how powerful the leak approach can be. Up to 3 years ago, we were very, very proud of our code coverage on SonarQube. It was 60-something, 65 to 70. And really our objective was to make it more than 70. And I can tell you we were struggling big time. And for good reasons. It's a web app, difficult to cover. We have a lot of legacy. We have APIs which are difficult to test. We had some frameworks, etc., etc. So lots of good reason not to manage to go beyond 70%. So this is really on the left-hand side. And about maybe 3.5 years ago, we really decided to go for this leak thing. So we said ourselves, okay, let's forget about the past. And now let's make it 80% on new code. We will not look at old code anymore. We'll just look at new code. We started to make it 80%. Of course, that was a change, so people had to adapt a little bit. But after a couple of months, people came back and said, it's okay. We just need to start thinking about testing when we write code, which doesn't sound like a bad idea. But it's fine. 80% is fine. So recently they moved to 85, and you can see that the overall coverage of the application has actually gone from 68, let's say, to 87% now. And all of this was done with pretty much no big effort. It's a continuous effort that you do basically every day while you are coding. And I think for issues it's very similar. If you manage to handle the new debt, basically you are gonna improve a lot your application. So that's for the left-hand side. On the right-hand side, you can see it's all about the leak. So basically, what we do is we do automatically compare with previous version of the software. So what you just ship to production is in production. So that's what you have to deal with. And now we will show you any new bug you introduce, any new debt. We show here the coverage on the new code. So 88.5 is actually we changed 6,600 lines since version 6.3, On these 6,600 lines, we have almost 89% of code coverage. So it's very, very focused on what has been changed since previous version. And once you have that, you can click on any metric. You get a list. You can see it as a tree, and you also get some nice information, and you get history, which is very useful. You can do that on pretty much every metric. So that's a problem when you test on a live system, which is released every day. Sometimes it doesn't work, so history doesn't work here. What else? I think I would like maybe to show one more thing, which is you also have here the ability to consolidate project information. So I showed you project information. Here, what I'm showing you is a team. So the language team here. So in the language team, we actually have 4 teams. One is called the .NET team. So you can see our project here. The Sonar Analyzer for C#, SonarLint for Visual Studio, etc., etc. And here we get a consolidated view. As part of the consolidated view, we also provide information about the risk here. So amongst 4 criteria, one is how releasable is your portfolio of project, how reliable, secure, and maintainable is your portfolio project. And we obviously also show evolution of this rating.
What does releasability mean exactly?
Releasability is whether the project they pass Qualityget or not.
Okay, so it's a result of the other ones?
It is, you are correct, except that reliability, security, and maintainability, we look at overall how it is doing. The releasability is done on the new code. So you could be doing a very good job right now on the changes you are making. So basically, developers are doing a very, very good job on the changes they are making, but overall the application is E. So
yeah,
it's
you
very
still definitely want to release it because it's going to be an improvement for your customers. So.
Well, then I think it's the other side of code quality that we are talking about now. It's more the management. Here, what we are trying to provide is a view of the state of the application. And here, you can make an educated decision whether you are going to ship it, whether you need to do a special effort of remediation or whatever. But we try to really separate the two matters. One is about the quality of what the developer are pushing should be very good, but they can't be held responsible for what has been done on the application for the last 10 years. If you make them responsible for this, and if you ask them to fix all of that, basically there is a good chance that they are going to quit very, very quickly. So we try to separate the two concerns. One is about, let's make sure that from now on, everything which shipped to production is good. The other one is, okay, for what is there already, for our debt, basically, what do we do? And here we try to give some insights.
Okay.
Right. And I think I will stop here the demo of SonarQube. I think you probably get the idea. What's important is, again, so we have showed IDE. I talk a little bit about promotion. Here we talk about the team, how they can handle this quality at the team level for configuration and reporting. I think we should say a couple of words on other things we are also providing. One of them is we provide the ability to analyze pull requests. So, the developer is going to have information in the IDEs and he's going to push his code. nowadays modern development tend to use pull requests. In GitHub, for example, what we have the ability to do is every time a pull request is created, we analyze the change set here, and we write the result of this analysis in the pull request, so that the guy who is going to do the code review, you know, he's going to review the changes, he's going to comment on that. He will also get information about the quality of the changes that was made. So again, he can make an educated decision to merge or to make changes or to reject. On the last thing, I don't know if we have time to show you the integration we have with MS Build, which was developed with the Microsoft people. What do you think, Bertrand? Do we have time to show that?
Sure. How long does it take?
I don't know, Tamás?
5 minutes. Let's say 5 minutes.
That's what you said for SonarLint, Tamás. 5 minutes, huh? I'm joking.
Okay, so I'm going to share my screen. So in the meantime, I just created quickly a quick demo. So yeah, I'm increasing the size.
Thank you.
So this is a simple C# application. It has a couple of issues in it. We can go through them, or we can just ignore them. So here what I wanted to show, this is like an obscure issue. You know how to turn off type checking in C#, use dynamic, and then you can shift with a floating point number, but that always throws an exception. So we report on that. But here's another one, which shows the data flow analysis, what it can handle actually. So if A is less than B, B is less than C, A greater than C, oh, that never happens. So we handle transitive relationships basically. So let's say I've got a C# class here, and I just quickly added a JavaScript file, which probably has issues, and we'll see if we have issues or not. And how do we analyze this whole thing? So we need something called SonarQube scanner for MS Build. How do you get that? You probably search for it, like SonarQube scanner for MS Build, first link, and then you can download it. It actually goes to GitHub, and it is a link to the latest release on GitHub. So as we said, open source, developed together with Microsoft. You can check it out, you can use it. So let's get back to Visual Studio. So let's analyze this thing. I've got the local SonarQube server running, and I want to analyze this thing. So I open a developer command prompt. How do you build? Yeah, and I'm increasing the size a bit. So let's say 20. So how do you build this project? You call MS Build. You say that you want to rebuild, and you say what you are going to build. You are going to build the solution. You build it, and voila, you built it. So how do you analyze this whole thing? You need two things. You need a begin step. So you are going to run the scanner for MS Build. I've got a shorthand for it called scan, but this is just calling an executable. You call the begin step and pass a couple of parameters. For example, what you need to pass a key, which is going to be the key on the SonarQube server. So for the on .NET, we pass a name. This is going to be the name of the project on the SonarQube server on .NET test. And you pass a version. Why do you need a version? Whatever Olivier showed you with the water leak metaphor, you need to know what's the new release and what's the old release. So let's pass in version 1. So I'm hitting enter. What it does, it goes to SonarQube, my local instance, pulls down some settings and stores it locally. Actually, it does a bit more. It does some MS Build magic. So now if I go back and build the project, you will see that we built it and we actually got warnings.
Oh, wow.
So what we do, we inject some logic into MS-build target files, and that is being picked up by MS-build. There's an imports before folder, which MS-build always checks if there's a target file there. And we pull down basically from the SonarQube server, we pull down the Sonar C# rules as NuGet packages, and that was added to the core compile step. If I can find it quickly, you will see that, okay, here's a DLL being passed as an analyzer. Okay, and one last step, and you need to run the end step. The end step actually parses the JSON report being output by Roslyn and pushes the data to the SonarQube server. It actually does a bit more. For example, it runs your JavaScript analysis as well. And then you take this link and go open it. And let's see what we have. So we've got 4 bugs. Let's click on them. Let's see them. So, okay, that's an error message shift, and it will fail. This condition is always false, okay. And we have JavaScript issues. So X is null, so X is known to be null here. So this will definitely throw an exception. And this is what I mentioned to you, that the JavaScript team actually infers the type of a variable. So if X is equal to 5, so its type equals to 5, then its type can't be string. So that's always going to be false. So that was a very quick demo. And just to mention it, so as I said, everything is on Visual Studio Gallery. So we almost have 100,000 downloads for SonarLint for VS. But we also have in the team services part, if you search for SonarQube, there's already VSTS integration. So you can just take this job, install it, choose your VSTS account, confirm. Okay, sorry, I already installed it. There are 2 confirm buttons on this page. Okay, I'm good to go. So I can go to my VSTS account and check out the project, go to build releases, add new definition, choose Visual Studio, why not? Let's say GitHub, because that asks only a couple of questions. So we've got a build setup. You would have your own build setup. In the add build steps, I can scroll down and find SonarQube scanner for MS build, begin and end. So I can add these. I can drag and drop these. As you've seen, the begin needs to be before the build step actually. And here you need to specify your SonarQube server, where it is. You need an endpoint. You need the project key, you need the project name, you need the version, and there you go. The end step doesn't require anything. So basically, you've got the same begin and end step as you would get on command line, but in this case, it's with a nice UI and it's running on your CI server.
On that plays very, very well with SonarQube, because suddenly you can start to schedule like daily analysis at no cost, basically. Because we integrate with MS Build, you do not have to change analysis parameter. You just run it on a daily basis.
Very nice. How do you guys make money?
I will let Olivier answer that.
Yeah, that's a good question. So we have just to give you an idea, about 80% of what we develop is open source, free and open source. Sonar C# is one of these things which is free and open source. There is also 20% which we sell. Some analyzers, they are not free. So the COBOL analyzer, for example, is not free. Mm-hmm. It comes at a price. We also sell support on the entire platform. Little bit of services, but we have a package which is called Enterprise Edition, which we sell to I would say, larger corporations.
Nice. And you're happy with this model of lots of open source and selling services and additional value?
Yeah, we are trying to sell mostly software. Actually, we are not professional services is not really it's not really our business model. We are very happy with that, especially in a field of code quality, which is not the code review audit is not the most sexy and attracting thing for people. So having this product, which is pretty good, open source, easy to install, no real entry barrier, I think is a pretty balanced model for the domain. And it enables people to enter also some deeper analysis. You see that I had many other examples I could have shown you in C++, COBOL, etc., but I think it was enough for today. You also get the you get the simple stuff. You also get the harder stuff, and I think it catches some pretty good things. So pretty happy with the model. Mentioned it quickly at the beginning. We have an we have an online version also, which is called SonarQube.com, which is only available for open source project right now. But in a couple of months, we are planning to also have the ability to analyze private projects, and it's going to be a paying offering.
That makes sense. Okay, so that's very interesting for people out there who have an open source project that they would want to apply those tools on. They can.
Yeah, they can, and they can do it right now. It's a couple of clicks to create an account and then to analyze projects. And we are really looking forward to also have the private part, which is going to play very well, I think, with VSTS. You could see the tasks that Tamás showed a couple of minutes ago. It's going to be like super easy from your built-in VSTS to basically send an analysis to SonarQube.com.
Excellent.
That's really looking forward to that.
Very nice, very nice. Thank you guys for the demos. Is there anything you'd like to add before we conclude?
I would say thank you for the time. That was very nice.
Of course, if you have any questions, we can answer that. But...
Absolutely. All right. Well, thank you very much, guys. And thanks to everyone for tuning in today. And we'll see you again next week. Bye, everyone.
See you
Thank
guys.
you. Bye.